You open Netflix. Without searching, without scrolling, the first thing it shows you is exactly what you want. That is not a coincidence. Hi, I am Mahaz, an AI engineer. Last episode, Arima and Profit predicted the future from past numbers. Today, recommendation systems, how every streaming platform, shop, and feed decides what to show you next. Episode 29, Recommendation Systems. Two completely different philosophies. Content-based filtering, look at the item itself. You liked an action movie with car chases. Here is another one. Same genre, same style. Collaborative filtering, forget the item. Look at the people. Find users who behave like you. Recommend what they liked. Content-based knows the item. Collaborative knows the crowd. Netflix and Spotify combine both. That is the hybrid approach. The user item rating matrix. Every user is a row. Every movie is a column. Every cell is a rating. Most cells are empty. You have not rated most movies. Neither has anyone else. That sparsity is the entire challenge of recommender systems. The job: predict what rating a user would give an unseen item. Fill in the blanks. Accurately. Cosine Similarity. Two users are represented as vectors, one dimension per item rated. Cosine Similarity measures the angle between those vectors. Angle near 0. Both users rate things the same way, very similar. Angle near 90 degrees, completely opposite tastes. It does not matter how many items they rated. Only the pattern matters. User-user versus item-item collaborative filtering. User-user, find the most similar users to the target user, then recommend what those users liked. Item-item, for each item the user rated, find similar items. Recommend those. User-user breaks down as user count grows into the millions. Item-item scales better. Items change far less than user behavior. Amazon pioneered item-item collaborative filtering. It is why it scales. Matrix factorization, how Netflix actually does it. Take the sparse user item matrix and factor it into two smaller matrices. One matrix, user preferences encoded as latent factors. Other matrix, item characteristics encoded the same way. Multiply them back together and the empty cells fill in. Those are your predictions. SVD, ALS, and NMF are all factorization approaches. SVD is the classic starting point. The cold start problem. A brand new user has 0 ratings, 0 history, 0 signal. A brand new item has never been rated by anyone. Collaborative filtering has nothing to work with. Solutions: ask new users for explicit preferences during onboarding. Or use content-based filtering first, then switch to collaborative once data builds up. Most production systems handle cold start with a hybrid strategy. Hybrid recommender systems combine content-based and collaborative filtering to cover each other's weaknesses. No history? Fall back to content-based. Enough history? Let collaborative filtering take over. Netflix uses both, weighted differently by how much data they have on you. Spotify's Discover Weekly is collaborative at its core, with content signals layered on top. Evaluating a recommender system. RMSE on held-out ratings. How far off are the predicted ratings? Precision at K. Of the top K recommendations, how many were relevant? Recall at K. Of all relevant items, how many made it into the top K? In practice, precision and recall at K matter more than RMSE. A recommender that predicts ratings perfectly but recommends things you never click is useless. In code, this takes about 15 lines. Build the user item matrix with pandas pivot table. Compute cosine similarity with scikit-learn. For production scale, use the surprise library. It handles SVD and evaluation automatically. Fit, predict, evaluate, the same 3 steps as every other ML model. If this helped, subscribe. Text classification with classical ML is next. Common mistakes. Evaluating on training data. The recommender just memorizes past ratings. Ignoring the cold start. New users get terrible recommendations and churn. Popularity bias. The system keeps recommending the same 10 blockbusters to everyone. Not retraining as user behavior shifts. A recommender trained a year ago drifts. Treating implicit feedback like explicit ratings. A click is not a 5-star review. Quick recap. Content-based. Recommend similar items. Collaborative. Recommend what similar users liked. User item matrix is sparse. The job is to fill in the blanks. Cosine similarity measures how alike two user preference vectors are. Matrix factorization handles scale. SVD is the classic approach. Cold start needs a hybrid fallback. Evaluate with precision and recall at K. Episode 30. Text classification with classical ML. TF-IDF, bag of words, naive Bayes, logistic regression on text. The first NLP episode in the series. Subscribe so you do not miss it. Challenge task. Build a movie recommender using Movie Lens 100K. Compute user cosine similarity and return the top 5 recommendations for user 1. Write which 5 movies came out and why. Solution in the repo. Netflix, Spotify, Amazon, YouTube. All of them running versions of exactly what you just learned. User item matrices. Cosine similarity. Matrix factorization. The algorithm behind every recommendation you have ever received. Episode 30. Text classification drops next. Subscribe. Which app's recommender impressed or annoyed you the most? Comment below.